So let's do the integral of the square root of x over the square root of x plus 1. What we need to do first is apply a rationalizing substitution. If we look at the integrand, we can see that it's not in the form of a rational function, which is a function in the form of a fraction where both the numerator and denominator are rational functions. So what we would like to do is to do a substitution to turn the integrand into a rational function, which is easier to work with. So let's just go with u equals the square root of x plus 1, which is the expression in the denominator, because that would make the denominator a single u term. Then let's just see what happens. If u equals the square root of x plus 1, then du equals 1 over 2 square root of x dx. We would now like to find an expression for dx entirely in terms of u. So if we multiply both sides of this equation by 2 square root of x, we get dx equals 2 square root of x du. In order to rewrite 2 square root of x du entirely in terms of u, we need to find an expression for the square root of x. So we substituted u equals the square root of x plus 1. So if we subtract 1 on both sides, we get the square root of x equals u minus 1. So we now have an expression for the square root of x in terms of u. So 2 square root of x du becomes 2 times u minus 1 du. So dx equals 2 times u minus 1 du. If we substitute all of this into the integral, it becomes the integral of u minus 1 over u times 2 times u minus 1 du, since the square root of x in the numerator equals u minus 1, and the square root of x plus 1 in the denominator becomes u since we substituted u equals the square root of x plus 1, and dx is replaced by 2 times u minus 1 du since we worked out that dx equals 2 times u minus 1 du. We can simplify this expression by bringing out the 2 outside the integral as a constant multiple, and rewrite the rest of the expression as a single fraction, so the integrand just becomes u minus 1 all squared over u. We can expand the numerator to rewrite it as u squared minus 2u plus 1, and the denominator is still u. And if we distribute the division, this becomes 2 times the integral of u minus 2 plus 1 over u du, since u squared over u is just u, and negative 2u over u is equal to negative 2. If we integrate term by term, the integral of u is u squared over 2, the integral of negative 2 is negative 2u, and the integral of 1 over u is ln of the absolute value of u. And all of this is multiplied by the constant of 2 in front of the integral. And of course, we also have to add the constant of integration c. If we distribute the 2 into the parentheses, we end up with u squared minus 4u plus 2 ln of the absolute value of u, and we still have the plus c at the end. We originally substituted u equals the square root of x plus 1, so if we substitute that back into the expression, we end up with the square root of x plus 1 all squared minus 4 times the square root of x plus 1 plus 2 ln of the square root of x plus 1 plus c. We don't need the absolute value in the ln term because the square root of x plus 1 is always positive, so the absolute value isn't needed. If we expand square root of x plus 1 all squared, we get x plus 2 square root of x plus 1, and if we expand negative 4 times square root of x plus 1, we get minus 4 square root of x minus 4, and the plus 2 ln of the square root of x plus 1 stays the same, and we also have to add the constant of integration c. If we combine like terms, we get x minus 2 square root of x, and we can disregard the constant terms because that's covered by the constant of integration c. So we just need to add the 2 ln of the square root of x plus 1 term and add the constant of integration c. Technically, the c in the final expression is not the same as the c in the previous expression, but I'm not going to worry about that, and just say that this is plus c. So the integral of the square root of x over the square root of x plus 1 is x minus 2 square root of x plus 2 ln of the square root of x plus 1 plus c.